Welcome back. In this video, I will give you an introduction to stack. It's an important data structure. I will give you the idea using a real-life example. Suppose you are typing this word. So this is a Spanish word, gracias, meaning thank you. Now, if you press backspace, then S will get vanished, right? You press backspace again, and A will get vanished. You press backspace again, I will be deleted. You press again, C will be deleted. Now, if you press Ctrl Z or undo, then C will be back. And if you press again, this Ctrl Z undo, then I will be back. You press Ctrl Z or undo again, and A will be back. And eventually, the S will be back, isn't it? Now, consider this structure. Look, in this structure, we have a closed end. That means nothing will pass through here. And we have an open end through which items can get inside or get out, right? Now, you notice one thing, that if you put something inside, then it will fall down somewhere here. And then again, if you put inside some other item, then it will be placed above the previous item. Similarly, if a third item gets inside, then it will be placed here. Let's say this is position number 1, this is position number 2, and this is position number 3. Now, when you get something out of this box-like structure, then this third item will get out first, right? And then the second item, and then the first item. So you see that the item which is getting last inside this box is getting out first, and which is getting first inside the box is getting out last. So it is actually a LIFO, that is last in, first out. Here we will see that how this box-like structure is used to get back the previous operations. Now suppose the backspace is pressed. So the S will get vanished or deleted. But without deleting it completely, what we do is that we take the S inside this box-like structure. Then again you press backspace. And of course, A will be deleted from this word, but A will be stored inside this box-like structure. Again, backspace. I will be stored. Again, C will be stored. And you notice that every time a new item is getting inside, the item is stored above the previous item, right? Now, you press Ctrl Z or undo, and you want to pull out the item from this structure. Then of course, the first item that will be out of this box will be C. Why? Because this is the open end and this is the closed end. Now through the closed end, you cannot pull out any item. So definitely C will come out. So we have C here. Then again Ctrl Z, then I will be there. Again Ctrl Z, A will be there. And finally S will be there. So to get back the previous data or the previous operations, what we have done using the Ctrl Z, we can use this kind of structure where one end will be open and the other end will be closed, and through this open end, item will go in and come out. Now this box-like structure, which is having one open end and the other end closed, and insertion and deletion, which we call push and pop operations, are there. So this structure is called stack. Okay. In this stack, we have one identifier and the name of the identifier is top. And its duty is to keep track of the topmost item inside this stack. So we have the push operation, which is actually an insertion, and we have a pop operation, which is commonly known as deletion. Now, during the push operation, you should ask what to push. But you should not ask where to push. Why? Because mind it that whenever item goes inside, the next item is placed above the previous item or the topmost item. So, in stack, there will be no way to push item in between other items inside the stack. For example, suppose an item is here, I1, and above that, I2 is there, and above that, I3 is there. Now, there is an item I4, which is ready to be inserted here to perform the push operation. Now, it cannot place I4 somewhere here or here or here. You are bound to put I4 above I3 because I3 is the topmost element now. So, I4 will be placed above the topmost item. So, the question here, where to push, is not valid. Now, during the pop operation, you should not ask what to pop. For example, the same example I will use here, I4, I3, I2 and I1. These four items are there. So, you cannot ask what to pop because I4 is the topmost element, and whenever you perform the pop operation, I4 is the only item that will be popped out. You cannot pop I3, I2 or I1 when I4 is the topmost element. And eventually this question is also invalid, that from where to pop. So what you perform? You perform LIFO, that is last in, first out. So whichever is moving last inside, that means here I4 is the last item which got inside, and it is the first item which will be popped out. So you maintain LIFO, right? So whenever you follow these rules that during the push operation, the item will be above the topmost item, and whenever pop will be there, then the topmost item will be popped out, and you maintain the LIFO, that is last in first out, then you are dealing with stack. Okay? Good. Now I give you the definition. A stack is a linear structure in which items may be added or removed, but only at one end. Right? Now, what about this linear? There are broadly two types of structures, linear structure and non-linear structure. The stack is a linear structure. But what about non-linear structure? In this course, later we will deal with lots and lots of nonlinear structures. I will give you a hint now about a nonlinear structure, and one of those nonlinear structures is a tree. Now you can see that if we say that this is node number 1 connected forwardly with node number 2 and connected forwardly with node number 3, then we get a linear structure, right? But you see here at node number 2, what is happening? One link is going forward to node number 3. Another link is going forward to this node. We call this node number 4. So on the previous side, it is having node number 1, and in the forward side, it is having two nodes, 3 and 4. So actually it is not linear. It is becoming non-linear because one more branch is getting out of this node number 2. But our stack is a linear structure. That means there is no way of branching thing here. Okay? So how will you implement this stack? One way is using array, and another way is using linked list. Now what will happen in case of array? Now this is the array here, you can see that. So here you have the 0 index here, 1 here, 2, 3, 4 and 5. That means there are 6 cells in this array. And you maintain one identifier. The name of the identifier is commonly used as top. So whenever an element gets inside, it will get placed in the 0th cell first, and then the first cell, then the second cell, then the third cell, then fourth, then fifth, in this way. So whenever a new item is getting inside in an empty stack, the new item will get placed here at the 0th cell. So top will be here. And then top will get out increasing like this as long as new items will get inside this stack. Got it? Let's take an example. Suppose we have these 6 items here and we want to get these items inside the stack. Then this is the visualization. Now since array starts from 0th index, so we initialize this top to -1. Now of course this -1 does not belong to this stack. So I have written over here just to make an indication. Okay. Now what will happen is that I will increment top by 1 so that it comes from -1 to 0, and then I will take this first item 44 inside that cell indicated by top. Okay? So let's have an increment here, and 44 has been placed in the 0th cell. How 44 comes to know that where to get inside? Actually, it is following top. The top is an indicator that where the new item is to be placed. Okay? So, whenever I want to place 55 inside this stack, the top must be here, right? Pointing to the first cell. Right? So, increment top and 55 will be there. Similarly, top will be second cell and 33 will be there, and 77 on the third cell, 22 on the fourth cell, and 66 in the fifth cell. So you can see that top is acting as a guide to the new item. Right? Now what will happen in case of deletion or pop operation? So when you perform pop operation, you just decrement top from here to here by 1. That means if top was at 5, you just get it down to 4. That's all. Now you don't have to clear this cell, this 66 here, the data is there inside the 5th cell. Because this data 66 in the 5th cell will do no harm to you, because top is standing at 4. That means the stack is having only 5 data now, and the topmost element is at the 4th cell because top is there. So whether data beyond the top is there or not, it doesn't matter. Now if you pop one element again, so definitely this 22 will be out because top is there. So just decrement the top by this. You get the data, of course you can get the data and do some business with the data, but you don't have to clear the cell, just decrement the top by 1. That's all. So like this, like this, like this, and whenever top will be further decremented and it will be having this -1 there inside the top, then we will say that the stack is empty. Okay. Now we will see how a stack can be implemented using linked list. Now you have the same series of data and we have a node here. The 44 is there and the node is located at 743, and the next pointer of this node is pointing to null. And here we have the new node which is having 55 inside and is located at 102. So what we'll do is that we update this null pointer here to 102 and this new node will get linked to the node at 743. So one item has been inserted inside this list. Similarly, we can have 33, that is a third item here in this new node at 784, and we update the next pointer of 102 to 784 and we have it linked. So you can see that after 44, 55 is there, and after 55, 33 is there, then after 33, we can put 77 here, then 22 here, and then 66. So what we are doing in this linked list is that we are following the rule which is declared by stack, that new item will be above the previous topmost item. So first, this one is a topmost item. Then when the node at 102 will be linked, then this one becomes the topmost, and then this one will become the topmost. And always you see that whenever the new node is coming inside, the topmost element is getting linked to the new node, right? So you can see that we are implementing stack using linked list. So this is using array and this is using linked list. So you have this definition here. The stack is a linear structure in which items may be added or removed but only at one end. We have push operation, that is insertion. We have pop operation, that is deletion. And of course, we have to maintain this push and pop operations in such a way so that LIFO is maintained. And in case of array, you have a top variable or pointer which will indicate the topmost position inside the stack. And if you use linked list, then you can use our old temp pointer to find out the last node in the list so that the new node can be inserted after this last node, where the last node will be treated as the topmost element in the list. Okay. Now, if you missed the video that how to delete or how to insert node at a given positions, so you can watch the videos from the linked list playlist, and in linked list part 9 you will learn how to delete node at a given position. And also before this, there's another video which will show you how to insert node at a given position where the last node has been handled properly. So I hope it's clear to you that what is stack and how stack can be implemented using both array and linked list. In the next video, we will learn how to push item into stack. Thank you for watching and take care.